Pleased to be here. Good afternoon, everybody. So, yeah, as Mark said, what I'd like to talk about in the next 20-25 minutes or so is BT's experience of using IoT technology in the smart city application area, in particular with CityVerve. CityVerve is a large smart city project funded by Innovate UK, part funded by Innovate UK. And I'll talk generally about the IoT and IoT ecosystems and the technology to support those, and also how that plays out in the CityVerve context. So at a fairly high abstract level, we could think of IoT technology as being in four layers. As I say, it's quite high level, but you have sensors of all sorts, sensing data about their environment, light sensors, bin sensors, sensors in vehicles, sensors attached to running shoes, sensors attached to cattle. All kinds of different sensors are out there, several billion already and projected to grow. And then, of course, those sensors are gathering data about their environment, which needs to be sent to the internet, in the Internet of Things context. So you need, clearly, connectivity, and a range of possible connectivity solutions are available, particularly for the access, for the local access networks. Having got all that data, we then want to aggregate it potentially on some kind of platform, some kind of data hub, which brings it together and exposes it in a kind of in a uniform way, almost an information brokerage, if you like, a one-stop shop for data, rather than that data being scattered around here and there in all kinds of different formats. Having got the data and exposing the data in an easy-to-consume way, of course, then we move on to the applications where people can build all kinds of innovative applications, smart parking, smart lighting, waste management, and a whole range of other applications, not only in the smart city context, of course, but also in agriculture, in retail. We're seeing all kinds of different vertical sectors starting to pick up and use this technology. And so if we think about those four layers, BT itself, we're not really in the sensor game. We don't manufacture sensors or any other kind of hardware, but as you would expect, we're very interested in the connectivity elements of an IoT ecosystem. And we have a range of different IoT connectivity solutions to fit different types of sensors, different power requirements, different data rates, different data volumes, different environments, how is it in a building or is it out in the open air? How much penetration do you need through brick walls or whatever it may be? So scale, power, cost, coverage and reliability, all factors which come into play. And there's not one size fits all or a single answer in the connectivity space. There's a range of different solutions, horses for courses. No doubt there'll be some consolidation and some simplification, but I think there'll always remain more than one solution according to the requirements of the particular problem at hand. So that's connectivity. But really what I want to focus on today is not so much that connectivity layer, it's much more around the data hub layer, what we're doing with data hubs in Manchester and elsewhere, and how that really plays the central role in many respects in the IoT ecosystem. So, as I was saying before, there'll be billions of sensors out there. They'll be providing vast amounts of heterogeneous data. So what we'd like to do is aggregate that data, economies of scale. If one person brings that data together, that saves a lot of other people having to do the same thing potentially. And also providing uniform access to data, which makes it very easy for people with innovative ideas for applications to come and get the particular data that they need for their particular application, thus saving them the cost of finding where that data is and how to convert it into an easy-to-eat format and so forth. And by providing this data hub in an information brokerage type role, we aim to break down silos of data in different vertical categories so that we can use data across those silos and also lower the barrier to participation. If you're an SME with a great idea for an innovative application, you don't want to necessarily go out there and talk to 7 different data providers providing their data in 7 different formats. We can take that pain away from them, that cost away from them, by offering a one-stop shop, essentially, to data, to Internet of Things data. And in this way, the platform, the IoT Data Hub, supports an ecosystem of partners, from data providers who may want to publish their data for various reasons, through to application developers who want to consume that data and build apps, and then, of course, end users themselves who want to use the apps for business advantage or for personal convenience or for whatever motive it might be. So that's the central idea behind and motivation for the use of a data hub in the Internet of Things context. I want to say a word about market size and interoperability. Probably like me, you've read quite a lot of analyst reports and seen all sorts of very big numbers, so I'm not going to claim that I know exactly which number is right, but I think it's going to be quite a large number in terms of market size. But the one that I was really interested in that caught my eye was the one from McKinsey, where they said interoperability is going to be essential to unlock 40% of the value of the IoT market. And of course, a data hub, by integrating data into a single platform, does go some way to address that interoperability problem. Having said that, we also need interoperability between hubs. There'll never be only one hub. I mean, BT would like to sell its own hub to the whole world, I'm sure, but there'll always be multiple hubs, and there aren't many greenfield sites out there, certainly not in the smart city context. There's always existing platforms and existing data that you have to integrate with. Therefore, interoperability between data hubs also becomes very important, and that's the role of the HyperCat standard, which has been developed in recent years by BT and others, enabling hub interoperability by providing essentially a machine-readable data catalogue to make it very easy for application developers and others to come along and interrogate a hub and understand the data that hub has available, what that data is about, what units it's expressed in, how you can access that data, what is the terms and conditions associated with access to and use of that data, and so forth. So HyperCAD is quite keen to describing data hub data in a uniform and machine-readable way that makes it very easy for people to come and understand the data on different hubs. And every hub can be interrogated in the same way. So, data hubs for IoT and for smart cities. I'm going to park that for a moment. I'll come back to data hubs at the end. I'll just move on to give you a little bit of context about how we're using data hubs specifically in the CityVerve context. And the observant among you will know that I've now changed the background to the slides to the CityVerve template away from the BT template. So CityVerve is Manchester-based. What you can see here, the coloured buildings on the sort of kind of 3D map there are define an innovation corridor from Manchester city centre at the top of the screen, heading south about 2 miles and about a mile or so wide. It's the location of a lot of the startups, the tech startups in Manchester. Also, all the universities are essentially in that area. So it's going to be kind of the proving ground and the demonstration area. They refer to it in Manchester as the innovation corridor. So that's going to be the main focus of the CityVerve work. As I've already said, it's a smart city demonstrator project for Manchester, which we hope will be replicable outside of Manchester. Obviously, we don't want to do work only for Manchester. It's got to be replicable elsewhere. The lead partner is Manchester City Council. It's part government funded, as I said, and we have 21 different partners. BT is one of the largest. We have various Manchester universities. Cisco are also a large technology partner, and then a whole bunch of SMEs, around 15 to 18 SMEs, mainly Manchester-based, also involved in the project. So we want to facilitate the build and delivery of a blueprint for a smart city infrastructure. It's a 2-year project which started in March, and we want to develop a model that's sustainable and replicable. So sustainable, i.e. it will carry on beyond the end of the project. We'll be able to deliver these things permanently into Manchester, and replicable, we'll be able to pick it up and replicate it elsewhere. 5 major work streams. Building the platform of platforms, which of course is where BT's Data Hub comes in. Engaging citizens, we see it as key that it's not a technology bubble project. It's one that gets out there and understands the needs of the citizens of Manchester and seeks to address their needs in the smart city context, and also businesses in Manchester, I should say. It's an open innovation project, and what I mean by that is that it won't only be the project partners developing the applications. So if you think about BT's Data Hub, gathering all that data together and exposing it in a uniform way, we want to then invite other SMEs and other organisations, those who aren't in the consortium already, to come along and access all that data and to develop their own solutions. And we'll be running a series of hack events, we'll be setting a series of business challenges, and we've very much encouraged third parties to come in and help us to build CityVerve applications. So all about open innovation. There's a series of use cases that we will develop within the project, as well as that open innovation agenda. And evaluation is key. We need to understand the business benefits and the citizen benefits of what we're doing. Those use cases that I just mentioned will be in four main application areas: travel and transport, energy and the environment, health and social care, and culture and the public realm. So those are the four key areas that we're addressing. But as I said earlier, we're also really interested in cross-silo applications. So quite an obvious one is energy and the environment. Air quality is quite related to travel and transport. So if air quality is bad in a particular area, you can measure that with sensors clearly. Perhaps then you can put in travel interventions around signage, around traffic light control and so forth, which will reduce the traffic congestion in that area, move the traffic down a different route through the city, and ease the air quality issue. So very much four key pillars, four key application areas, but also about interworking between those. These are the partners. As I mentioned, Manchester City Council are the lead, Cisco and BT, the two largest technology providers, and a whole bunch of other names there, many of which you'll recognise. So in short, it's a £15 million collaborative project. UK government is putting in 10 million. It will run for 2 years from July. It's about large-scale deployment of IoT, connecting all sorts of different sensors, large-scale smart city demonstrators, and central to this will be BT's Data Hub, along with the Data Hub of several other partners, interoperating via the HyperCat specification that I mentioned earlier. And key to the whole thing is replicability, sustainability, and scalability, as you would probably expect. So a slightly more detailed look at the BT Data Hub, kind of supporting an information brokerage or information ecosystem, as I said before. We have data consumers who take data out and have the benefit of accessing that data in a uniform way. We also have data providers, such as people in the CityVerve context, Manchester City Council, Transport for Greater Manchester, and many others who are providing data to the project. We have developers developing the apps based on the data, and we have end users who are using the apps for their own benefit. Slightly different view on the same basic idea. We can see the sensors and the other data types at the bottom there. As I said earlier, there's then a variety of connectivity solutions which feed the data into the hub. Data providers can easily onboard their data. They can specify the terms and conditions and the pricing policy and the privacy policy applying to their data. The information spine is all about the highly scalable access to that data. That's a BT developed capability. And then you have developers who can access the data through a developer portal, which lets them build and test applications and deploy applications back into the portal. And then finally, top right, of course, as I said before, you have the apps with the end users using the apps. And what I'm going to do now is attempt a live demonstration. Always slightly dangerous, but so what we're looking at here is a dashboard. This particular view is simply looking at our two hubs, the alpha and the beta versions, and it's checking the latency. So you can think of this as like sending test data through the hub, and then consuming that data with a test application and just checking. This is all about really essentially just checking the status of the hub. So let's move to something that's perhaps a bit more interesting, and I'm going to use smart parking. And I forgot that I need to log in, which will take just one moment. This is actually based, this specific example is based in Milton Keynes, where we have another smart city project, but we will be looking to do similar types of thing in Manchester. And what we can see here is, in fact, a map. What we cannot see here, I've just realised, is there any way we can switch away from the PowerPoint to the browser, guys? Thank you. I'm getting a thumbs up, so apologies. You probably didn't see that last when I was... Did they see anything, Mark, when I was burbling about the latency?
It's a big build-up.
Okay. Okay. Well, we'll wait for the browser to appear on the screen. I can't hear that.
Exit the presentation. Exit the presentation.
Okay. Thank you. Didn't really want to exit. Okay. Too bad, I guess. Okay. We have something. So, yeah, this is a map of Milton Keynes, and over here, central Milton Keynes in green there. This is live data, and it's showing you that currently 75% of parking spaces are occupied. We also have information down here about the type of bay and so forth, and we can just zoom in a bit. We can also see on the dial here that we have 75% occupancy across the city right now. What I want to do is actually zoom in to show you we can actually go down to a very fine level of detail if we wish. So you can see here each of those blue or green rectangles is an individual parking space, and you can see in this particular car park there's only one green right now, so a very full car park. Each space has a sensor on it using NB-IoT, I believe, to send data back to an aggregator point and then back call over Wi-Fi. No, SIM card I think it is in this case. Anyway, and then it's aggregated on our hub, and this is just one example of an application that we've built using the hub and using some of the data that we're collecting in Milton Keynes. And this one actually turned out to be quite interesting, because Milton Keynes has no space for new car parks because of planning regulations and so forth, and they were planning to build. So the only way to build new car parking spaces is to build up, i.e. multi-storey. And that worked out really expensive, as you can probably imagine. I think it was £15,000 per new space. So they wanted to really avoid that. And with the data that we've provided them and the kind of analysis that we've provided them with, they realised that some of their car parks are currently underutilised. So they are now looking at a policy, rather than investing in the multi-storey, how do they direct some drivers from the centre out to the less utilised car parks. So a real benefit there for a local government who, as we know, costs are being driven downwards in local government. So doing more with less, or doing more with at least the same infrastructure. This is a report that we can generate from the car parking. This is all the car parks in Milton Keynes on a kind of built up chart, and you can see each of the spikes is essentially a day, and you can see that occupancy peaks kind of in the middle of the day, and it goes really low at kind of 4 in the morning, which is exactly what you'd expect. And these two lowest peaks are a Saturday and a Sunday. So I just wanted to show you that to give you an idea of one of the applications that we've built, albeit that one not in Manchester, but the one I'm about to show you is in Manchester, although I cannot show it live. So here we have some air quality sensors in Manchester, and I mentioned previously about correlating traffic congestion through sensors with the air quality that we can also measure through sensors. And essentially we're measuring air quality over time. You can't really read that very well, I'm sure, but the peaks tend to coincide with rush hours, and then this period here where air quality is very good, in fact, essentially coincides with the middle of the night. So you can monitor this in real time. You can see as things are starting to build up. And as I was saying previously, there's the potential there to put in traffic interventions to change the traffic around the city to bring the air quality, to improve the air quality in areas where it's getting critically bad. So just another example there, where we're actually combining two different types of sensor data to try and improve travel and air quality around the city. So time is telling me that I've run out of time, which is great because I'm on to my last slide. So in summary then, I would say that CSPs have key roles in the Internet of Things ecosystem as I've tried to outline it. Connectivity is of course the obvious one, but also I think the platform play, the data hub idea is also an area where operators can usefully add a lot of value into this space. And more widely, it's about, I think, for us supporting the whole ecosystem end to end, but through partnerships. So we won't do everything where we're not doing it ourselves. We'll do it through partnerships. Something I didn't have time to touch on today, but of course, mobile operators already have several hundreds of millions of sensors through smartphones in the UK. So each smartphone these days, everyone in this audience knows, has quite a lot of sensors on, and that is a very rich source of data. Modulo, of course, privacy and security concerns. BT is trialling this model, this ecosystem model, with the use of our data hub in CityVerve, as I've said, but also elsewhere, some of the sectors that we're looking at, smart agriculture, chicken sheds, believe it or not. What's the temperature in the chicken shed and how much feed is left in the feeders? It's quite important, apparently. Transport and logistics. MK Smart is another smart city project, which I showed you the parking demo of just a moment ago. And also we're starting to do some work in the retail sector. So with that, I'd like to close and thank you very much for your attention. Sorry about the browser glitch there, and I'm more than happy to take any questions. Thank you for your time.